Okay, first of all, we can just ignore this important, do this or you're doomed. Look at the periodic table from the class for clarification. Basically, what that was pointing my students in the past to is I needed them to add the ionic charges onto their periodic table, but I've done that for you with my new awesome periodic table, so let's just ignore that part there. So let's go on to number 2. Give the chemical symbol for the noble gas that each of the following look like by gaining or losing electrons. For instance, F would try to look like Ne. So here's fluorine. It wants to gain 1 electron, look like neon. So let's try this here. Here's silicon. The deal is, here's the line dividing the nonmetals from the metals. Nonmetals tend to gain electrons, and metals tend to lose electrons. So silicon, being on the metal side, the nonmetal side of the stairs, is going to want to gain to look like argon. And then we have Hg is mercury. Mercury is going to try to lose whatever valence electrons it has in the 6th energy level, so it can look like xenon. Remember, metals are metals because they have loose electrons, so therefore metals always lose electrons. And so it's going to try to look like xenon. Let's find arsenic. Here's arsenic. Again, it's on the non-metal side of the stair, so it's going to gain to look like krypton. And then we have magnesium, which is over here. It has 2 valence electrons in the 3rd energy level, so it's going to lose those 2 and end up looking like neon with a completed 2nd energy level. Then we have iodine. Obviously, it's going to gain 1 to look like xenon. And we have radium. Radium's over here. Oh, no, it's not. It's over here. Radium has 2 valence electrons in the 7th energy level. It's going to lose those 2 and end up with a filled 6th energy level and look like just like radon. There you go. Okay, let's take a look at number 3 here. So for each of the following, we're going to write either gain or lose to indicate whether it gains or loses electrons, and then indicate the most likely number gained or lost. So for instance, for fluorine, I would say it's going to gain 1. So look at, here's nitrogen. It's everything on here gains, and everything on this side of the stairs loses. So it's on the gain side of the stairs. So nitrogen is going to gain, and it needs to gain 1, 2, 3. So I'm going to say gain 3. Then we have gold. Now gold is a transition element, so I can't just look and see how many valence electrons it has in its column, which makes it a little bit trickier, but it's not that bad. One thing I can do here is I can just look in the box. Let's just make this a little bit bigger here. If we look in the box here, what we see is here is the most likely ionic charge is +3. So a +3 charge means that what it's going to do is it's going to lose, so let's put L for lose, it's going to lose 3. Now let's find niobium. If I look at niobium, I see niobium here is +5. That means it's going to form a +5 ion. In order to do that, it has to lose 5. Now I see we have argon here. Let's try to make this a little smaller. Argon is noble gas, so it's not going to gain any. So it's just, we're just going to write none. Noble gases don't gain or lose any. Now the next one we have is silicon. Silicon is, we see, a -4. That's because, oops, I didn't mean to do that. It's a -4, and that's because it wants to gain 1, 2, 3, 4. So I'll put G4 for gain 4. Then we've got silver. Silver again. Why am I giving all these transition elements? What is with me here? Oh my gosh. Are you serious? Okay, well, alright, what we're going to do now is we're going to say, well, here is silver. I see a +1. +1 means it wants to lose 1. Osmium, I just keep going. Okay, osmium, I see it says +4, which means it wants to lose 4. And then uranium, good heavens. Uranium, oh, look at that. It wants to form a +6 ion. In order to form a +6 ion, you're going to have to lose 6. Well, this next one is not too bad, so I just have to tell me what the most likely formed ionic charge is. And again, my new periodic table sure makes this awfully easy. So let's find chromium. There it is, +3. find strontium. There it is. Whoops, I didn't mean to do that. There it is. It's going to be +2. And then sulfur is over here. It's going to be -2. And lead, well, lead is over here, and lead is going to be +2. That means it loses 2 electrons. And carbon, -4. -4 means it, well, importance of -4. Ion, which means it gains 4 electrons. Let's find iron. Iron, I see it's a +3. Protactinium. What the heck? Why would I ask about that? Well, let's just try here. Protactinium. I don't even know where the heck that is. PA. This is embarrassing. Oh, here it is. Okay. Alright, it's way down here, and I see a +5. Okay. What was I thinking? +5. In other words, it loses 5 electrons. And then arsenic. Arsenic is here. It's a whoops. Arsenic is over here. It's a -3. Indicating that it has a tendency to gain 3 electrons. Now let's look at the next one here. Whoops. Okay, now what we want to do is we want to give the name of the most likely ion, the ion most likely formed. So here's where you've got to be a little bit careful. So chromium. So I look here. Here's chromium. Let's make it a little bit bigger. Now what you have to do for metals is this. You have to see, in addition to its most likely ionic charge, does it have others? In the case of chromium, the answer is yes, it does. Now if I look at scandium, it only has 1 ionic charge. There are no others that it forms. But chromium has more than 1. So it's most likely to form a +3. But I've got to be able to tell a reader that it's not +6 or +2, so I cannot just say chromium. That wouldn't be sufficient. So instead what I have to say is, since it's likely to form a +3, I'm going to have to call this capital C, chromium, and then Roman numeral 3. And what that Roman numeral 3 is telling me is that this is the +3 variation of chrome, as opposed to the +6 or +2. Now let's look at strontium. Strontium, where'd you go? Here's strontium. Now if you look at strontium, strontium is always a +2. There's nothing else here. You know, it can't have other ones like, say, niobium or molybdenum. It's always a +2. So I don't have to say 2. It's understood to be 2. So when I talk about strontium, all I have to say is strontium. Let's see if I can spell strontium. Strontium. You know, I hope you appreciate how hard it is to write with this darn stylus. Okay, now sulfur. Let's look at this next one. Sulfur is over here. Sulfur is a non-metal. It's on this side here. It's a non-metal. For the non-metals, all we have to do is we have to remember to put "ide" after it. So instead of calling it sulfur, I'm going to call it sulfide. Let's try another one here. We got lead, Pb. If I look at lead, it's a metal. Got to be careful. In addition to +2, it could also be a +4. I've got to tell the reader, am I talking lead 2 or am I talking lead 4? So what I do is I use Roman numerals. In this case, the most common one, I've already forgot what the most common one is. Is it 2? Pb is 2. Okay. So I'd say is lead, and I put a Roman numeral 2 to tell me it's the +2 lead ion as opposed to the +4. Carbon, well, here's carbon right here. Carbon is a non-metal. Since it's a non-metal, it's going to change its name to ide. So in this case, I'm going to call it carbide. Turns out there's not a lot of carbides out there, but there is one, like calcium carbide. Here's iron. Okay, so iron is right here. If you notice, it could be a +3, a +6, or a +2. I have to be specific, so it's a metal that can make more than one. So in this case, I'm going to say it is iron. And I'm going to put a Roman numeral 3 to let the reader know it's the +3 variation of iron. Pa, no, here we go again, but now, at least I know where it is now. Pa is down here, and you'll notice Pa could be +5 or +4. +5 is the most likely, so therefore The most common one, most likely one to form is going to be, oh, do I have to write protactinium? Grrr! Okay, I'm going to try it. I'm going to do it down here. It's protactinium. Darn it. And the most common one was 5, and the Roman numeral for 5 is V. Alright, that means a +5 protactinium ion. And finally, I have arsenic. Arsenic is a nonmetal. And since it's a nonmetal, it's on this side of the stairs. I changed the last name to Ide. So I'm going to call this one arsenide. Awesome. Let's keep going. Well, let's see. Can we keep going? I'm going to try to move this up. Let's see. Oh, I can. Look at that. Okay. When naming an ionic compound, simply give the name of each ion. It's as easy as that. Just remember to capitalize each ion's name and include a Roman numeral. Okay, here we go. Plus V plus 4 and P3. So I have a compound out of these two. So what I'm going to call this one is, well, let's just see. There we go. So let's look here. V is vanadium. And vanadium makes lots of different ions, so I have to be specific with Roman numerals. So for this one, I would call it vanadium. In this case, I had to say Roman numeral 4, which is IV. And if you don't know your Roman numerals, look on the back of your periodic table. I've listed the Roman numerals 1 through 6 back there. And now phosphorus is going to change its name to phosphide. Phosphide. Our next one is chromium. Chromium plus 6 and iodine. If I find chromium here, look, here's chromium. It can be plus 6, plus 3, or plus 2. So since it's plus 6, I have to be specific. So I'm going to call this one chromium. And I have to say 6, which is Vi. And I have to do that because it makes more than one ionic charge. And then iodine, I'll change this name to iodide. Zirconium and carbon. Alright, well, let's find zirconium here. Let's see. Zirconium, you'll notice with zirconium, it's always plus 4. It's only plus 4. I don't need to use a Roman numeral if there's nothing else to confuse it with. So in this case, I'm just going to say zirconium, and carbon is going to change the name to carbide. Carbide. Our next one is copper. If we look, copper. Copper could be plus 2 or plus 1. So I'll have to use Roman numerals to be specific. This is plus 1. So I have to call this one copper 1. And sulfur will change its name to sulfide. And finally, I have aluminum and arsenic. I think finally, is that finally? Let's see. Yeah, that's finally, okay. So I have aluminum and arsenic. Here's aluminum. Notice aluminum is always plus 3. It's only plus 3. There's nothing else here like there is, say, here. Since there's nothing here, that tells me I don't have to use a Roman numeral. It's sufficient just to say aluminum. And now arsenic is going to change his name to arsenide. Now, are we done with our homework? Let's see. We might be. Is there anything else here? Oh, look at that. We're done with our homework. Oh, that wasn't so bad now, was it? I hope you enjoyed it as much as I did.